Hi math lovers, welcome to notes number 65, lesson 3.4. We're going to do a second day of the zeros of polynomials. I have two fun problems for us to think about today. The first one is number 49, and it's going to tell me, it says find the function with real coefficients, and it's going to give me the zeros. Now, before I even get started, I see that I in there, don't I? So this is, I'm taking a look at this 3 plus I root 2, and right away I know there's one more, one that's not listed. It must be the conjugate, all right? A second one. So that's going to be 3 minus I root 2. So now I have 1, 2, 3, 4 roots. I'm ready to get started on my problem. So the first thing I'm going to do is write this in f of x form. And I've got 2/3. So I could write that factor as 3x minus 2. If you want, you could write it as x minus 2/3, but come on, your honors. You probably want to write it as 3x minus 2. And then you've got -1, so that's going to be x plus 1. My next factor that I have here, parenthesis, it would be x minus, I'm going to keep it neat, I'm going to hold it together, 3 plus I root 2. And then my last factor that I have here, my last zero, is going to be x minus, parenthesis, 3 minus I root 2. Okay, phew, let's clean this up. This will be f of x is equal to 3x minus 2 times the quantity x plus 1. And then I'm going to distribute the minus signs here. I say it all the time, but I tend to have a little bit of problem with the minus signs. That's going to be, let's see, x minus 3 minus I root 2, and then x minus 3 plus I root 2. This is kind of interesting. I don't know if you guys see this, but as I said it out loud, I was kind of thinking about these two terms being together. What if I rewrote it as x minus 3 in parentheses minus I root 2? Look what's coming together. Oh my goodness. Do you see it? It's the difference of two squares. So it's x minus 3, the quantity squared. You see it? Perfect. If I FOIL this together, I've got perfect square and another perfect square, I root 2, perfect square. Wait. Yeah, that's right. I root 2 squared. Hold on. I was so excited I had to just stop for a second. And then I would have the minus underneath, right? The minus in between. So is that going to work for me? Let me just stop and think about how this is going to play out. Minus, yeah, that looks good. Oh, I forgot to bring all these terms down. Oh my goodness, and my excitement. My f of x. All right, so I'm going to go one step further and I'll say 3x minus 2 times x plus 1. Okay, now I'm going to have to FOIL this out. My first term here, that's easy for me to go ahead and multiply. That's going to be x squared minus 6x plus 9 minus, now let's see, I have I squared. Maybe I should just write it out. I squared times 2, right? Because I square root 2 and I get 2. Oh, look, it's beautiful, isn't it? This is going to be x squared minus 6x. This is going to be positive 1 times 2. 2 plus 9. Oh my gosh, 11. Oh, I just love it. Isn't that great? So I have taken a problem that looked like it was a big imaginary mess. And instead, I have written that function with real coefficients. Oh, just gaze at that. It's so beautiful. Now, Ron goes a couple steps further. And Ron rewrites the whole thing by FOILing it all out. Be sure when you check your answers in CalcChat, he's going to write this in the fancy form. He's going to say a times the quantity, 3x to the 4th minus 17x to the 3rd plus 25x squared plus 23x minus 22, all right? He's going to go ahead and write it that way. Either way would be fine. I'm pretty happy stopping right here. You've convinced me that all of my imaginary numbers are gone. I do like the a in the front. That's also a very good thing to do, okay? All right, let's try another one. Number 55. You're going to love this one. You're going to just love this one. This one, I'm going to give you the function x to the third minus x squared plus 4x minus 4. And I'm going to tell you one of the zeros is 2i. Now, I know what you're thinking. How can I have real coefficients, right, if I have a zero that's 2i? What's the other zero? Yeah, negative 2i, all right? So I'm really telling you I have two zeros. Now, there's a couple ways you could go with this problem. I probably would write this as f of x is equal to, let's see, I would say, because it's a power of 3, right? So maybe we would write it as 3 sets of parentheses. I would say x minus 2i, x plus 2i, because those are the two. And then I don't know that third one. I wish I knew what that third factor was going to be. But what if I went ahead and I multiplied these two together, x minus 2i and x plus 2i? That's another difference of two squares, isn't it? So that would be x squared. Let's see, 2i squared. That's going to be 4i squared. That's going to be negative 4 minus, so that's going to be plus 4. Oh my goodness, look at this. I have x squared plus 4. How could I figure this out? I just did long division earlier in the week. How about we take x squared plus 4 and we divide it into x to the third minus x squared plus 4x minus 4. Okay, that sounds like a great idea. I've got x squared. Something times x squared is x to the third. Well, that's just going to be a plain old x. X times x squared is x to the third. And x times 4 is 4x. I have to be so careful. My 4x is going to go here underneath its like term. I did not use a placeholder. What was I thinking? Oh my, well, I wasn't, right? I wasn't thinking. I need to then go ahead and subtract. So I'll change the signs of both of these. And these will fall out here. Oh my gosh, and that falls out there too, doesn't it? Let's bring down what we have left. Minus x squared and minus 4. So something times x squared has to be negative x squared. That's just negative 1. Negative 1 times x squared is negative x squared. Negative 1 times 4 is negative 4. Oh, isn't that beautiful the way it lined up? And I go ahead and I change my signs because I'm subtracting. And look at my remainder. My remainder is 0. Now, if my remainder were not 0, something would be wrong, all right? We have figured out that the x minus 1 is going to end up right in there. And so the other 0 that they were looking for, so all of their zeros, which I think is what the question asks, is 2i, plus or minus 2i, and positive 1. All right, so that's what they're looking for. Now, maybe you weren't thinking long division. Maybe you wanted to try, I don't know, synthetic division. And you would go ahead and you would take your 2i. All right, so this is an alternate method. So from this point up here, you would come down and you would put 2i as your divisor and use your coefficients here, 1, negative 1, 4, negative 4. Okay, so that's a funny looking eye. There we go. I'm going to go ahead and bring my first term down. That would be 1. 1 times 2i is 2i. So I have negative 1 plus 2i. Oh gosh. I've got to multiply, so that's going to be negative 2i. 2i times 2i, that's going to be negative 4. Oh, look how pretty this is. So now I've got negative 2i that I bring down because these 4s will fall out when I add up. Multiply those two together, and I get positive 4, and my remainder here is 0. Okay? It should be 0 because I'm telling you what the 0 is. Now, let's take that other term, negative 2i, and let's divide it into what we have left, 1 minus 1 plus 2i, and negative 2i. Okay, so I'm dividing it into it, just like if I said to you, hey, I have a number, and these are two of the divisors, find the other divisor. So I'm dividing it into what I've already divided. Now let's bring down the 1. 1 times negative 2i is negative 2i. Add these up and I can bring down my negative 1. Negative 1 times 2i is positive 2i, and I am left with 0. This is my remainder. Not my donut, it's my remainder. Now my last step is to variable this up. Since I have, let's see, highest power up here was a 3. So now I'd be down to a 2. Now I'd be down to 1. This last factor is x minus 1. And isn't that what we found when we did our long division way up here? That is just beautiful. That is just beautiful. So 2 really fun problems that we worked through today where we're thinking about our zeros and we're thinking about getting real coefficients. Do not forget that if they tell you you have an imaginary root and you have real coefficients, your other one that's not given to you, it's like a little trick, is the conjugate. Okay, don't forget that. Have fun with your problem set, kids.